In our world today, the periodic table organizes the elements in horizontal and vertical rows. The horizontal rows are arranged by the order of increasing atomic number. The atomic number equals the number of protons in the atom's nucleus of each element. The elements organized in vertical columns are based on similar physical characteristics and chemical behaviors. The arrangement developed side by side with the atomic theory over a span of about 200 years. And it continues to evolve as new elements are discovered. One of the earliest attempts to organize the elements based on their chemical and physical properties was made by German chemist Johann Dobereiner. In 1817, Dobereiner noticed that certain elements that were chemically similar could be grouped together in threes. For example, calcium, strontium, and barium. In the group of three, the atomic weight of one element fell halfway between the atomic weight of the other two elements. The pattern seemed too remarkable to be a coincidence. Based on his findings, Dobereiner proposed the law of triads in 1829. His work soon prompted other scientists to find patterns among even the larger groups of elements. Another attempt to organize the elements based on their properties was made by the French geologist Alexandre-Émile Bigord de Chancourtis in 1862. He devised a kind of spiral graph that was arranged on a cylinder, with the elements ordered by increasing atomic weight and with similar elements lined up vertically. De Chancourtis was the first to notice the periodicity of elements. When the elements were arranged according to their atomic weights, similar elements seemed to occur at regular intervals. A year later, an English chemist named John Newlands also attempted to classify the known elements based on their atomic weight. Like de Chancourtis, he noticed a repeating pattern in which every eighth element had similar properties. Newland called this the law of octaves. Although the tables worked out by de Chancourtis and Newlands were important aids to the periodic table, neither received much attention or credit at the time. A Russian chemist named Dmitry Mendeleev is acknowledged as the father of the modern periodic table. Mendeleev wrote out the names of the elements along with their atomic weights and other properties on cards, which he then laid out in rows and columns. When the elements were ordered according to atomic weight, Mendeleev, like Chancourtis and Newlands, could see that certain chemical properties were repeated periodically. However, not all of the elements fit this pattern neatly. Mendeleev's solution was to move certain elements to new positions, despite their accepted weight, in order to group them with other elements sharing similar properties. Mendeleev's work on periodic law states that the properties of elements recur periodically as their atomic weights increase. This was announced in 1869, which was about the same time a German chemist named Julius Lothar Meyers independently arrived with a periodic table that was remarkably similar to Mendeleev's. Unfortunately for Meyer, Mendeleev presented his work first to the scientific community. However, Mendeleev's table was also superior to Meyer's because he left a number of empty spaces to account for elements that were yet to be discovered. Because Mendeleev made a risky prediction that turned out to be true, he got credit for the periodic table. The first major change to the periodic table occurred following the discovery of an entirely new group of elements, the noble gases, between 1895 and 1901. They were called the noble gases because they were believed to be inert, which means they're incapable of reacting with other elements to form compounds. These elements were simply added onto a separate column under helium. The first major revision of the entire periodic table was carried out by Henry Gwen Jeffreys Moseley, an English physicist who began his research under Ernest Rutherford. In 1914, Moseley showed that each atomic nucleus could be assigned a number that was equal to the number of units of positive charge, which we now know as protons, associated with it. Once the periodic table was reorganized according to this atomic number instead of atomic weight, the few discrepancies in Mendeleev's system disappeared. Over the years, other revisions of the table have been made, including the incorporation of rare earth elements, lanthanide series, and the synthetic elements, technetium, promethium, and all the elements with the atomic numbers 93 or higher. The actinides, which are radioactive and mainly synthetic, and the lanthanides do not fit in the same pattern of the repeated properties as the other elements, so they are generally shown below the periodic table in separate rows. Most of these changes were the work of American chemist Glenn Seaborg, who co-discovered elements 94 through 102. Between 1940 and 1958, Seaborg also suggested a superaconide series of elements with atomic numbers 122 through 153, but so far none of these elements have been synthesized or detected.